Continuing the previous example, I will work with the same data, but I would like to do some other type of plot. So once again about the data itself, here we have the electricity spot price and we have the regulation price up and down. So if this value of regulation, for instance regulation down equals electricity spot price, but regulation up is higher, then it means that in that hour the price was regulated upwards. If it was vice versa, so if actually like in here regulation down is lower than spot price and the regulation up is equal, then it means price was regulated down. And if we have a case where all these three are equal, that means that there was balance, so there was no regulation neither up nor down. So I would like to make a plot where I plot the regulation price, which is, or for instance I plot spot price, but then if the price was regulated up, I'll kind of plot a point above the spot price, for instance in red color, that marks that regulation up. And if the price was regulated down, I want a, let's say, green spot below my original spot price. And then maybe if there was balance, then I just want a black dot on that spot price curve. So let's try and do that. I'll use the data, the data I've loaded before and it's already saved as a MATLAB file, so we don't worry about that. And then in here from the plot, I will leave these just in case. These ones are probably not so much needed, so let's comment them out. Okay, so now I know my spot price is in the second column of the data, and then the regulation prices, let's see, that's regulation down is 5th and up is 6th. So probably it would be useful to make some kind of additional column in my data which actually keeps track, just as a marker, whether we had regulation up or down, or maybe it was a balance. So I will call a vector reg for regulation, and I want to make it as long as, for instance, the spot price vector. So it's basically, let's make it zeros, and we want as many rows as our data itself, so actually we can just say length of d. Yes, that's the numeric, and one column. Alright, so now I just have vector full of zeros, but in that vector full of zeros, those places where my spot price equals both regulation up and down, I want them to remain zeros. But if there are places where spot price is higher than regulation down, that means regulation and actual regulation down, so those values, for instance, I want to be marked as -1, and then regulation up, so where regulation up price is higher than spot price, then I want there a marker 1. So there are two ways. We could use a loop and go for every row one by one, or we can simply use logical indexing. For your benefit, I will do both. The quicker and neater one is logical indexing, so I'll start with that one. So basically what I want to do is that I want to find where in my D matrix regulation down was the 5th column. If that one is less than the spot price, which is in the 2nd column. So if I run this, I'll just get a vector of zeros on one saying yes, no. And wherever this condition is true, I want my reg vector. In those very places, I want that one to have value -1. So all I need to do is say that for my regulation vector, and those rows where this is true, put value -1. Now what I added here, I know that my vector has, I know it's just a column vector, but just in case I'm marking that for all one column do that job. So it could have actually worked without it, but just as a habit working with matrices, it creates a good practice that you are aware of how your vector is actually oriented. So this one is column vector. And now in the very same way, the only thing I have to do, copy paste. Now regulation up was in the 6th column, and now if that one is higher than the spot price, then I want that row to get value 1. So when I run this and check what is my reg, you will see it will have a bunch of zeros and ones. So neatly, just in 2 lines of code, we actually took care of the entire vector and entire data set. Now as a loop, if we do it with a loop, we would have to visit all the rows individually. So I'll say for I from 1 to, once again, length of our data, we say that if in that particular row 5th column value is less than the same row 2nd column, so again regulation down is below lspot, then I want my, I call it differently, reg with capital R, that particular value of my vector I want to be -1, else if similar thing but 6th column, so regulation up, higher than lspot, I want it to become 1, and else reg I becomes 0. Now notice I didn't put any more else if or else this equals that and this equals that. No, because else already knows if it's not this and this, if this is not lower than that, and if this is not higher than this, it means the only thing left is those zeros. So now I need to end if and another end for for loop. So this does the same job, but well, for some people loops are easier to understand, especially when you start, because you can trace what happens in every step. For others, logical indexing feels better, and logical indexing as such is faster. So it is the better way, but it's not the necessary way. So if you feel more comfortable with loops, you can still use those, but it's good to know how this works, because you may come across codes that you will need to use for your own purpose at some point, and if they have logical indexing, it's at least good that you understand how things are written. So now what is left is actually to do the plotting I said. So first I'll just plot the spot price, and that was the 2nd column of my data. Okay, let's just keep it at that. Yes, and now I wanted, we can add axis type, though axis type is better at the end when we have everything on the plot, but I wanted to add things on top. So now, what did I want? I wanted to plot now regulation up points, but only those which were actually, there was up regulation. So, I will plot here, because now, here I didn't put x component because I didn't need to. I could still say 1 to length of data. So that's my y, and that's my, that's my x, that's my y. Now in here, I will not have all the index points between 1 and length. I will have some chosen ones where a specific condition is true. And which condition? Well, the fact that our vector has value 1. So I want this to be valued 1, but that's not enough for me because this gives values 0, zeros and 1s. I want to know where they are, and that's why I need to use find in here, because find will tell me, for instance, it's row 10, 11, 15, 16, 17, 25, and so on. And it's those locations I need. But that also means that from the regulation up data, which is in 6th column, I don't plot all of them. I only plot the same ones in the same locations that I found a while ago. That they do contain this reg vector being 1, equal to 1. And let's say regulation up, so I would like to have them in red color as red points. Okay, let's run and see what happens. So now let's zoom in. Maybe I should have taken a shorter piece of data. But you see, those points are such that they are above our L-spot curve, and that was the idea. Even here, even though they seem almost there, they are a little bit above the respective spot price. Now, in the same way, without much even coding, we just copy this and do the respective thing, but for regulation down. So the difference is we take it from the 5th row, and we want our regulation vector to be now valued -1, and we want, let's say, to give those green color. And now we can make axis tight. So let's also plot our balance points right away. So we wanted them black. That means our reg vector has actually value 0, and then we can take it up from L spot, so from the spot price vector. And let's put the legend. So in the order how we plotted stuff, we had first spot price, then we have regulation up, regulation down, and the balance situations. Okay, let's run and see. So we zoom in, and now you can see those few examples. So whenever we have upregulation, the red points are above you, so you see how much the price was upregulated. Balance is on the L-spot curve, and regulation down is green points below the L-spot curve.